unmute my speaker. That might be a good thing. Okay, guys, welcome back. Hope you enjoyed your 4-day weekend. It was definitely too short. It was profitable for me. I won my golf tournament and I won $5. Yeah. Do you have $5? Do you have $5? I don't hear him saying he has $5. I have $5. So I doubled my allowance. Yeah. Once you're married, you find out that what's yours is hers and what's hers is hers. Okay. So get used to that when you're married. That's why I've been married forever. Okay. So today we are going to be, I got to share the screen. That would be a good idea. And I expect Amanda to log in shortly. Share screen. Share. Okay, so today we're going to go back to our friend the Trig stuff, okay? Looking at ratios. We're going to use the unit circle. I'm not saying you have to memorize it, but there's some that you should know, okay? Like you should know 30, 45, and 60 of the sines, cosines, okay? You should know. And then we're going to look at some properties of exponents and logs. And then, oh, there she is. And she's not showing her face. Don't know why. She's so incredible. Anyways, hi, Amanda. So we're just starting the lesson. So here's our unit circle. Everyone's familiar with it. On our Canvas page under resources, I have a picture of the unit circle, or you can do the Googles and you can type in unit circle, whatever you need to do for it, okay? Then some things just to remember about the unit circle. Instead of us having X and Y, they're always cosine and sine, okay? So if I want cosine of pi over 4, oh, here's pi over 4, cosine's the first one, it's going to be root 2 over 2, okay? Everyone good with that? All right, so it's always sine, cosine. Then other things we have to know. Tangent is equal to sine over cosine. Right, you remember that? Okay. Sohcahtoa, the great Inuit chief, the guy who lives in that Eskimo village up in Tuktoyaktuk. His name was Sohcahtoa, and he's the one who invented trigonometry. Trigonometry is Canadian. I bet you didn't know that. Now you do. Okay, so if I wanted like the tan of, let's say tan of pi is going to be the same as sine of pi over the cosine of pi. Sine of pi is 0, -1 is equal to 0. Okay, everyone good with that? You guys all remember that, I hope. Thumbs up from Amanda. She got that, right? Yes. Thanks, Amanda. No thumbs up. I'm hurt. And then some other ones. We got something called the inverse functions, okay? And the inverse functions were cotangent, secant. Okay. We got cotangent, secant. Let's see if I can move that over so I can see it. And cosecant. Cotangent is equal to a couple things. It's equal to cosine over sine, and it's also equal to 1 over the cotangent. Secant is equal to 1 over cosine, and cosecant is 1 over sine. Okay. This is just review. Hopefully you guys remember a little bit of this. Okay, all good? Good. Questions? Okay, let us do this. This is going to be a really pretty short lesson, okay? And homework might take you 20 minutes at most. And you're going to have most of the class to do it. So we want sine of pi over 6. Sine of pi over 6. Remember, here's our unit circle. It's always cosine sine, right? So I go to pi over 6. I want the sine of pi over 6. So what do you got, Zoe? 1/2. Yep. 1/2. Damn, why did I choose tan of pi earlier? My goodness, I didn't mean to do that. We did this earlier, right? This is the same as sine of pi or cosine of pi, which is 0 over -1, which is 0, right? Not pretty easy. Like, I think so, right? You guys all good on that? Let's take a look at the next one. Oh, we want the cosecant of pi over 2. Well, that's the same as 1. Wait, what's up? Oh, sorry, man.
It's all right,
All right. And Xavier, this whole presentation is going to be on Canvas. I'm gonna, because I'll post a link to my YouTube page, and this is where it's gonna be. Okay. Fantastic, man. You must be like the 10 people who freaking are watching my videos. Okay, so now I got 1 over, and what's my sine of pi over 2? Sine of pi over 2 is 1, right? So 1 over 1 is not 0, it's 1. Why did I say 0? I'm done. Okay, this one a little bit different. Where is the cosine equal to -1? Where is the cosine equal to -1? Huh? At pi. There's our answer. That's it. So you can see here at -1, there's my cosine, right? It's that thing, and we can see it's at pi. We will never use, I don't like using absolutes. 95% of the time we will be using radians, okay? We will be using degrees. Let me amend that. 99% of the time we will be using radians. I can't even think of when we will be using degrees anymore, okay? Just the way it is. Okay, exponent log properties. Again, this is on the Canvas page, okay? Under resources, all of these rules, couple of the important ones for us. The log of 1, any base is equal to 0. The log of b to any base, if these two are the same, always equal to 1. And rule 7 is probably my favorite, okay? That's a really, really, really good one, okay? And the reason it's a good one is because if this thing and this thing are the same, the bases are the same, it's equal, and this thing here is called an index, it's equal to the index, okay? Now, we don't use logs a lot. We use the natural logarithm, the ln. And what we have is that the log of x to the base e is equal to the ln of x, okay? So we're going to be using ln more than we're going to use log, like a lot more. And the reason we use, the reason I'm showing you this is because we're going to apply this property here a whole lot. So if I say e to the ln of x, that's equal to x. because our bases are the same, right? They're both base E, so it's just equal to that index. Everyone good? Any questions? Amanda, any questions? Excellent. Okay. Now, let's do some real equations, okay? I shouldn't have to, but I'm going to every single step. I will not be doing every single step in the future, okay? Subtract 1, okay? And I get e to the x equals 1. Okay, now if I go back and I look at my properties, and where is it? I swear it was here somewhere. It's not there. One of the properties is sort of rule 5, Amanda. If we got, let's say anything to the power of 0 is equal to 1, okay? So we can say x is equal to 0, okay? This is sort of a basic property. You said 5, Amanda, let me look at it. 1, 2, 3, 4. It's sort of this one, the 0 exponent, okay, property, okay? Anything to the power of 0 is equal to 1. Ln of x equals 0. And this is one of our properties that says the log of 1 to any base is equal to 0, okay? So in this case, x is equal to 1. And I can do something sort of cool with this one. Cool because it is math, okay? I'm going to do something really cool with this. I have the ln of x equals 0. And then I'm going to do something called exponentiate, okay? So I'm going to rewrite this as e to the ln of x equals e to the 0. Everyone good with that? Does that make sense? Yeah? Well, here I know my bases are the same, right? So I know this has to equal x, right? You good with that? Good, good, good. Y'all are good? Edwin? Okay. Anything to the power of 0 is equal to 1. Okay, so same way to get the, or sorry, different way to get the answer, okay? But I just wanted to show you because we'll be doing this method a whole sort of lot in the future, okay? And last one I want to do is this one. Ooh, any ideas? Ideas on how to do this one? I see blank stares. Can I give you a hint? If I had a, no, let's do this. X to the B times X to the A, what's that equal? You're close, Amanda. This is equal to X to the A plus B, right? Now, I can rewrite this, right? As e to the x plus x minus e to the x, right? You agree with that? Because x plus x is 2x, right? But notice that when we multiply this, right? Or when we're adding these together, this is the same as e to the x times e to the x. Oh, I heard it. Oh, I get it. Now, what ideas do you have that we can solve this? What'd you say? I thought I heard something over here. What's common in this? What's common, Chanel? E to the power x, right? So e to the power of x is common. And I'm left with e to the x minus 1 equals 0, right? All good, good, good. All right, now, what this means is I have two solutions, okay? I have e to the x equals 0, e to the x minus 1 equals 0, okay? Let's look at this first one here. Is there any value of x that's going to make this thing equal to 0? Yeah, no, yeah, Xavier? What value of x would make this equal to 0? 1? So someone said 1. So if I got e to the 1, well, that's equal to e, right? Huh? E to the e, well, that's really e to the 2.81, which is a really big number, right? That's like 27 point something, okay? Okay, well, we're getting there. Any values of e to the x? 0? -1. That's close. So we say e to the -1 is the same as 1 over e. That's just a fraction, right? It's like 1 over 3 almost, or 1/3. Is it 0? No. Hey, if I give you the graph of e to the x, you think that might help? Okay, so let's do the graph of e to the x. And let's see what we get. And these are my graphing skills, okay? Will e to the x ever touch 0? No. So this one has no solution. Oh, I fooled you. Does not exist there, right? Never going to e to the x will never equal 0. Then the second one, we got e to the x equals 1. We did this before, right? And where does e to the x equal 1 when x equals 0? Beautiful. Okay. You guys all good with that? That was sort of a cool question, right? No, this is only pre-calculus. We haven't even got to the calculus part yet. Okay, so you guys are doing questions. What was it? Up to 54, I think. Yeah, something like that. You have the rest of the class to do it. I'm here. You have your partners. You can help. They can help you. Okay. Amanda, I'm afraid you're on your own. Unless you want to like FaceTime Zoe or something. That'll work, okay? Yes, up to 54 in the packet. Guys, take a picture and then upload it, okay? Guys, all good? Any questions? Amanda, do you mind if I shut down the Zoom? Amanda's not answering. Amanda's not answering. Do you mind if I shut down the Zoom? Okay, thanks a lot for joining us.